This meeting is being recorded.
Yeah, good evening, sir. This is Group 16 again, presenting explainable AI for our top two best and the two worst models. So our best models, we had the XGBoost and the Ensemble, which is a combination of the XGBoost and the Random Forest. These models outperformed the rest, as we illustrated in our concept paper. And the worst two, we had the logistic regression and also the stochastic gradient descent model. Yeah. So for the XGBoost, which was the best, performed extremely well. On the y-axis, we have the features. X-axis, we have the sharp values. The features are feature 30, 40, 25, but there is a mapping right here in the script that matches which feature number belongs to which channel. Yes, during training, we removed the channel names, but we decided to add them back after. Okay, we couldn't add them back, so we just created this on the side so we can refer to it. But yeah, you can see feature number 30, the top for the XGBoost, feature number 30, number 40 and 45 and 25 are the ones that contributed significantly to the XGBoost's predictions. And when I look at our feature number 30 is PZ, and also feature number 40 is F6. When we read some research papers, we realized that F6, this is in the frontal region of the brain. This region of the brain is very crucial when it comes to arousal. It's critical for decision making, and it helps with cognitive abilities. Yes, so this showed the mere fact that the XGBoost was depending on these features for prediction. This shows that it was generalizing well and identifying the correct patterns in the data. And then when we looked at the Lime explanation, for the Lime explanation, we could see that for class 0, for it to classify as for it to classify certain data as class 0, it would look at the feature 34, 46, 18, 11, 28, 29, and feature 0. So feature 34 is our feature F8, yeah, and all the rest. So if the value of feature 34 is between negative 3.47 and 0, that will cast a vote for class 0. Just as you see here, feature 34 was negative 0.83, and that casted a vote for class 0. Same thing here, if feature 46 is greater than 6.50, then that classifies a vote for class 0, which is 20, and here the value was 20.12. So that gave the class as class 0. Then when you look at class 1 also, if feature 39 is between these two values, that is negative 3.47 and 0, then feature 39 classifies to be as class 1. Yeah, so this is carried out for all the features until a final class is determined. The reason, so normally after prediction, there's supposed to be some bit of probability here, like class 1 can be 0.7, class 0 0.3, but for us it's showing 1 because we used a sample from the training data set to come up with all this. That's why it's really confident that this value is 1, because it's what it trained on. I'll invite my friend to talk about the partial dependency of the XGBoost. Yeah, thank you.
Yes, good evening. Yeah. So I'm going to be talking about the partial dependence, yes, of the XGBoost. And so now here we see, as my colleague already said it, and now this graph is majorly to explain about how the feature 0 affects the partial dependence. And so at the first, I think we can see from 250, it's the same. At 150 to 500 is the same, 750 is the same, 1000. Yeah, So here it shows that yes, the feature 0 has no effect on the partial dependency. Oh, the feature 0 has no effect on our module. Yes, that we decided to use. Yes, one of our XGBooster. So I think due to time, we can proceed to the next slide. Please, Joshua, your mic is muted. Unmute.
Okay, thank you, Bob. So as I told you earlier, this was one of our worst models, the SGD. That's a stochastic gradient descent model. So what happens here? So here we can see feature 0, it contributed some bit, this bit to class 1 and this bit to class 0. Feature 5, that bit to class 1 and that bit to class 0. And yeah, this happened for all these other features, and then there were some features that didn't contribute anything at all. So I think if we had removed these features that weren't contributing anything at all, because the features are quite many, they're about 143 features. If we had removed these features that weren't contributing anything to the model, this would reduce the noise to the model performance. This would reduce the noise and maybe improve its performance. Yeah, but I think that gives that explains the poor performance of the model. But either way, we can still see that it was depending on features 0, 5, 20, and 40. Feature 40, as we had seen earlier, is a very crucial point. Is a very crucial point for classifying arousal. But then feature 0, yeah, those can also explain the model's poor performance, because these aren't used a bit. Yes, and then yeah, yes, I will invite my colleague to talk about the partial dependence of feature 0 on the SGD classifier.
Yes, good evening once again. Yes, I think here we can see that there is a difference, this partial difference of feature 0 on the SGD classifier. Yes, I think here we can see that the feature 0 affects the partial dependence, because at first, some, let me say around like 150, yeah, there is an effect on the partial dependence, yeah. It raises up to 0.999. Then after that, after 150, 200, and also 200 and 250, 500, it remains constant, like totally nothing changes. Yeah, but at least here we see that there is a change at the partial dependence. Yes, please. Can you move to the next slide? Joshua, times against us, please.
Yes, so this is also the logistic regression. It also has features. It was also one of those models that didn't perform so well. But as we can see, all the features contributed evenly. They all contributed evenly. These features here, feature 40, 30, these features contributed equally to the model's performance. But we still have an issue of that noise from other channels, which could, if we had removed, maybe we would have improved the performance of our model. But we are just seeing it right now, which maybe explains the model's poor performance. But that's the whole point of explainable AI. It prevents AI from being a black box, and we can see what it's basing on to make its decisions. And that is what we're doing right now. Then we also have the line explanation of the logistic regression. It's the same thing as I had explained earlier. We have features and we have the ranges. So each of these ranges define which that once a value belongs within that range, it identifies as this class. Otherwise, maybe it can go to the other class. But as I told you, we are using a sample from the training data set. That's why it's giving 100%. prediction. Therefore, that's 1 out of 1. Yeah, in spite of the fact that it's classifying things, in spite of the fact that it's misclassifying. But yeah, I think you get the whole picture, Bob. Yeah, you can come in and talk about the partial dependence of feature 0 and the logistic regression output.
Yes, well, yes, I think also here we can see that it's the same as the partial dependence which we have seen of recent, that here also still the feature 0 affects the partial dependence. So at the partial dependence, yeah, we're having different values ranging from the negatives to the positives. Yeah, so here we see that the feature 0 ranges from negative 5.984 to around negative 0.988, and also crosses to the positive side, that is of 0. Yeah, 0.022. So still, it looks like the same graph, because at around like 150, yeah, in feature 0, there is a rise. Then it reaches 0.022, it remains constant. So like nothing totally is changing. Yes, Joshua, time, please proceed to the next slide.
Yeah, then also we had the ensemble model, which was our best as well. It was our second best model. So we can see it was feature 9 was contributing significantly to its predictions, both on class 0 and class 1, followed by feature 0, and other features followed. Yeah, and we also have its ensemble line, its line explanation, which is just as I explained. It's the same thing for other previous ones. For a particular class, we have ranges, and if a feature falls between that range, then it can identify as it casts a vote for a particular class. Then in the end, we have a prediction probability of whether class 1, or whether that feature whether that data belongs to class 1 or class 0. Yes, Bob, you can talk about the partial dependence of feature 0 on the ensemble so that we conclude.
Yes, well, I think so here, yeah, the partial dependence of feature 0. Yes, on ensemble models output looks like the one of the first one of XGBoost, because now here still we see the feature 0 totally does not affect the partial dependence. Yes, because straight away from the beginning, like 150. Yes, the partial dependence is at 1.00, so it remains constant throughout, meaning here it does not totally affect the partial dependence. Yes, thank you for listening, and have a good evening for now.